All right. I hope it's more visible. This question, this part specifically is not from the chapter. So let's keep moving on. Not from the chapter either. Yeah.
So this is from reactivity series.
Right. This is from the chapter.
Mhm. Okay.
A little bit from the chapter, not completely, but yeah, you can always go for it. The problem with these two chapters are they're so well connected into one another that usually the questions are mixed up so much you can't separate them.
Mm. So painting, it can be car body.
Right,
Um, bucket.
right,
And oiling, it can be bicycle chain.
right.
Mm. Sir, what's the first one?
Galvanizing, where we
Uh-huh.
mix a zinc with iron to form something. The process is usually known as galvanizing. It can also be used in another way, that we can make anything that we want to make out of iron. And then we put a small layer, a very thin layer actually, on the top of that iron of zinc to make sure that the iron don't rust.
So I think for this one, it can be railway bridge.
Galvanizing?
No.
Mm-hmm. What else?
Um, car engine.
Car engine, good.
Only food can is left. It's not painting. Okay. Uh, oiling? No. Mm.
All right, let's move on. I think that's a good example. If we're supposed to choose three of them, you choose two for each, just one left from one. That's fine. Okay, moving on. Uh, yeah, this one's good. Three, part A, part one.
State Y reaction in stage one is described as reduction. Mm.
Remember how we used to put oxidation states on top of elements, whether they were alone or they were in the form of a compound combined with some other element that can be a metal or a non-metal. So use the
Mhm.
same trick. Go ahead, see which one is getting reduced.
So it's hydrogen.
Think about it. That's not right.
Mm.
Okay, let's do it with me. And I'm going to think out loud, put out some questions, and you're going to give me the answers. In the same way, we'll get to the whole explanation or understanding of this. So which one out of these have the zero oxidation state just because they're alone? They're not combined with any other element in the stage one.
In the first stage or the second stage?
First stage, because the question is about stage one.
Um,
If you go with this equation, this whole equation, take a look at this. Which elements are alone in this equation? They're not combined with any other element. Of course, the
there are two.
oxidation state would be zero in that case. That is
So there are two, right? Hydrogen
right.
and nickel.
Perfect. Hydrogen zero and nickel zero. Now let's talk about the first one, nickel oxide over here, NiO. All right. So in this case, the state of oxygen is usually
Two.
2 minus, right?
Yeah. Yeah.
So in order to balance the whole thing, what would be the state of nickel over here?
+2.
2 plus, very good. In this case, water we have as gaseous form over here at the end of the equation. So oxygen again over here would be
1.
no oxygen. How come that's
Oxygen will
1?
be -2.
Minus 2, that is right. What about hydrogen?
+1.
Plus 1, since there are 2 atoms, so we are going to multiply that by 2 in order to get it right. Now notice, nickel is going from 2 plus to 0. On the other hand, hydrogen is going from 0 to +1. When you go from a smaller number like 0 to a bigger mathematical number like +1, the change is known as oxidation. And vice versa, when you go from a bigger number, which is 2 in this case, to a smaller number mathematically speaking, which is 0, the change would be reduction. So why is this stage reduction? I hope now you can answer part 1. Now for 1 mark, you can easily answer this question by simply stating which substance reduced into what? Don't forget this one reduced into this one. So what would you write as your answer?
That nickel oxide has been reduced to nickel.
Perfect. So the answer would be this stage is described as reduction. You may repeat the words. It's entirely up to you. You can do it even without repeating the words. So nickel oxide has been reduced to nickel. And that's a perfectly good answer. It gives examiner the whole idea that the student knows which substance has been reduced into which substance, and he or she understands that this change is because of what kind of electron transfer changes, loss or gain, whichever one is there, has been discussed. All right. So I think that's a perfectly good answer. Let's move on. That's not it. That's not from. That's of course a metallic bonding question. Part B, part 1, you are going to talk about the arrangement of particles in nickel, and that is definitely a question from metallic bonding because you're going to draw that whole diagram of metallic cations in a sea of delocalized electrons. I hope you already got that. So moving on. This is the same explanation. We're going to explain why nickel is malleable and a good conductor of electricity based upon the fact that there are metallic cations in a sea of delocalized electrons. But that's not from the same chapter, so let's keep moving on. So yeah, this one. Do you remember what
Yeah,
compound
sir.
was present in hematite?
Uh, it was iron.
There are equations given below, so it should give you a very good idea. Now you can even see all the equations. So which iron compound?
No, sir. I don't understand the question. Like, what are they trying to ask?
Iron is present in the form of raw material, in the form of its ore in this whole process. That's why we convert that iron ore into pure iron. Now, the equation over here that converts iron ore into pure iron, that iron ore is commonly named as hematite. They are
Mm-hmm.
asking you which compound is present in hematite. So out of these equations, which compound do you think is actually commonly known as hematite?
Sir, D.
This one, very good, D. So that is iron,
Oxide.
and then a 3. No, there would be a 3 and then oxide. Now, students tend to pick this formula up and write it over here, Fe2O3. Now, you're perfectly correct, but that's not what the examiner asked. See, you're supposed to name it. So if you write the formula instead of the name, that would be incorrect. You lose your marks. So never be
Mm-hmm.
too quick in the paper, never be too not vigilant enough in the paper to not see this kind of starting question word. Moving on. The next one is limestone. Of course, out of these equations, there is an equation which we break limestone into two parts, which we of course later on use. Remember what limestone was,
Mm.
or are you lost?
I don't know, sir. Limestone.
Okay, so this was limestone. This is calcium carbonate. Calcium carbonate was limestone. This is commonly uh, a big part of limestone. This is also present in the form of chalk. This is present in the form of eggshells. This is present in the form of marble. So calcium carbonate is actually present in many forms, or actually a bigger part of these forms.
Mm-hmm.
All right. So
Yeah.
moving on, let's talk about these equations. Yeah, the same question we practiced before. This is a good one. This is actually the repetition of that exact same question. Now you can see the whole question. Go ahead, solve it out. Let's see if you can remember what we
Yeah.
studied previously.
Yeah. So, sir, for the first one, it's A.
A, very good.
Second, it's E.
E,
This one, it is. It's B.
B, very good.
Okay. C, two. C.
C. Good. This was what we were talking about earlier, a reaction that forms the reducing agent, which later on reacts with hematite to produce pure iron.
Mhm.
So, since you get that, moving on. Part C,
Molten slag.
molten slag. Well done. Part D, part 1.
Mm, because it has high melting point. Hmm?
No, that's not it.
Mm,
He's talking about why do we use electrolysis in case of aluminum, but not the blast furnace process. That's what he's talking about.
oh, acha. Because it is like above carbon, so it won't react with it.
Right. So it's above carbon or it's more reactive than carbon. A perfectly good answer. Aluminum is more reactive than carbon. So carbon cannot displace it from its oxide. Part 2.
Because electricity is used.
Good. Part E.
Carbon. Uh, sir, is it because it reacts with oxygen?
No, that's actually an after effect. That's more of an after effect, something we really don't want to happen, but happens as collateral. Think about the reason why carbon is there in the first place. It's there, hence it reacts, but why is it there? Why do we need it? What do we need it for actually?
Um, because it doesn't react with anything, is it? No. Uh,
Yeah, a side reason, but not the main one. So you can't get the mark for it. So let's
okay.
talk about the main purpose of it. What is carbon formed in the reaction? Carbon is actually used to make something specific in that reaction. What is that something specific?
Um, so I'm not sure about this one.
The electrodes are made up of carbon. To be exact, it's graphite. And what are electrodes used for? They're used to conduct electricity in the electrolyte. Electric rods, electrodes, ring a bell? Graphite is inert, can be a fairly good conductor, hence conducts electricity in the electrolyte. Make sense?
Yeah, I got it.
Good. Moving on, the last part.
Oh, this one. Sorry, the first equation is Al3 uh, plus 3 electrons, then that arrow, and then Al.
Perfect. Next
Then
one.
for second one is 2O2, 2O2 arrow, um, 2O, no, O2, O2
Right.
plus 4 electrons.
Perfect. Great. So this is liquid because it was molten. This becomes liquid again because the temperature is good enough to melt it. This was liquid because it was molten, but oxygen is a gas.
So is it important to write those?
Writing state symbols is sometimes important, not always important, but it's better if you write state symbols,
Uh-huh. Okay.
right? Writing the state symbols gives examiner the idea that you perfectly understand what this equation is about and what the substances, what state the substances are in during that time or in that specific equation.
Right.
Is that good enough?
Yeah.
All right. So